So let's talk about MIPS, or MIPS, whatever you want to call it. MIPS stands for Microprocessor Without Interlocked Pipeline Stages. MIPS is a standard architecture used when deciding which registers are to be used for which instruction and how to write out your assembly instructions. This is very convenient and helpful when trying to decide which registers will be storing the final output and which registers the data is being pulled from. Like I mentioned earlier, MIPS is a standard architecture that we will be using, so that means everyone using MIPS will be using the same registers to store the same values. In general, registers 8 through 25 always store your temporary values. The 0 register always stores the value 0, and registers 2 to 3 always store your return values. When using registers, it's important to note that the data you're going to be using is not the number of the register. It is the number stored within the register. So register A in this example stores the value of X, and register B stores the value of Y, and register C stores the value of Z. All instructions cannot be combinations of other instructions. For example, there is no subtraction instruction because it's just an addition of a negative. We'll be looking at three different types of instructions: R-type, which is register, I-type, which is immediate, and J-type, which is jump. We need to remember that each of these 32-bit instructions have different representations, and in order to differentiate between which instructions we are working with, we need to pay special attention to their opcodes. You can tell an R-type instruction off the bat because the first 6 bits are 0. Following the first 6 bits is the S register that is 5 bits long. Following the S register is the T and the D registers, respectively, which are also 5 bits long each. Following the D register is the shift amount, which is 5 bits long. When we don't use an instruction that includes a shift amount, we ignore the shift and write out 5 X's because we don't care about the value here. And following the shift amount is the function code, which is also 6 bits long. You can tell an I-type instruction off the bat by looking at its first 6 bits. It will be non-zero and of type I. Following the opcode is the register S, which is 5 bits long. Following register S is register T, which is also 5 bits long. And following register T is the last 16 bits, also known as the immediate value. This is what you will be completing your instruction with. Our final type of instruction is J-type. It's the simplest as well. The first 6 bits are non-zero and of type J, and the last 26 bits are your memory address. An R-type instruction will have the first 6 bits being 0, while an I-type or a J-type instruction will have the first 6 bits being non-zero and of type I or J. Every memory address that you call on has to be word aligned. This just means that the last 2 digits in binary must end in a double zero, which conveniently in decimal is just a multiple of 4.